Welcome to my project. Here, I have taken the project as mushroom classification. Let's do the exploratory data analysis first on the project. So here I am importing the pandas library, numpy library, matplotlib library, and I am just loading my data and see whether my data has loaded correctly or not by using data.head. After that, I'm just checking what I need to predict. Like I need to predict here as poisonous or edible using, that means the class is the one which I have to predict. So I'm just visualizing the class using Seaborn. Here it's somewhat it's a balanced data, I can say. It's edible or around 4208 and poisonous are around like 3916. So it's somewhat quite a balanced data. And here I'm just visualizing what are the columns that I have, and I'm just predicting. I'm just want to know like what are the value counts. So here you can see, like here I have the classes two I have two only the classes. And here you can see there are six types of cap shapes. Here I have four types of cap shapes. Here around more than six types of cap shapes. Here two types of bruises. So I mean like there are different types of the data. So that data must be scaled. Here from this one I can say that the data must be scaled. After that, I'm just looking for info that is the data type is correctly matching with the column types or not. So here it's a mushroom classification data is mostly the categorical data. So the data type must be the object. Here as you can see here, most of them are the objects only. Here I have used data.describe to check whether there are any columns that doesn't require to be on the data to train my machine learning model. So here as you can see here almost all are like minimum of two types and maximum of 12 types here I can see. So and the wheel type doesn't to be there. I mean like it is only one type. Like most all the wheel types are the same only. So I don't require this wheel type data. So either I have to remove the wheel type data, or I can see whether my model predicts correctly or not if the wheel type is present, and I can see whether it's affecting my model's accuracy or not. So I have used the RF, like random forest classifier, to classify my data. So here also I have imported pandas library, numpy library, matplot, and load just the data. And here I'm taking X as my independent features and Y as my dependent feature. Here first I'm encoding my dependent features, because there are two classes of the data, which is edible and poisonous. So it will the label encoder encodes the data, like it will give 0 and 1 to the date to the y, like edible and poisonous. And I am also encoding my independent features too, because you see there are six types of one type has six features and another has eight features, some has four features, some has two features. So it encodes it such that it will be easier for the machine learning model to predict it. And as the independent features are not on the same scale, like as I already told, like six features, eight features, two features, so those are not on the same scale. So in order to be them on the same scale, I am using the standard scalar library to scale the data. After that, I have splitted my data using train test split. Like my training data is like 80% and my test data is like 20%. And I am importing the random forest classifier, just simply importing and just training them. I just save this RFC, random forest classifier, with the encoder, label encoder, and LE class. LE class is like the predictor for the dependent variable. Here I have used LE class to predictor for my dependent variable SC, standard scalar. And I just predicted my X test, and I just taken the accuracy classification report and confusion matrix. As you can see, my accuracy is like 100%. And this is my confusion matrix. 843 is a true positives, 782 is a true negatives. And that's my RF model. So in order to be able to be my model accessed by the user itself, I have created the Flask model. Here I have imported the Flask request and render template, pickle, numpy, and logging. This is where the logging will be there. Here everything will be saved to app.log. And here and this is my pickle model which I have saved using the pickle in the previous one. Here I have saved. Here, as you can see, here I have saved my mushroom classification rf final.pkl. So here I'm just importing that one, and I'm importing random forest classifier as model, and encoder, that is the label encoder, le class label encoder class, and scalar. So here, the when everything is loaded successfully, then the log in the log file, the model encoders and scalar are loaded successfully will be printed. Otherwise, error loading the model encoders or scalar, then going to this is my home page. Like index.html is my home page where everything will be present. Here, these are this list this is the list where, I mean, like, the user will give some input now. So the cap for cap shape, cap surface, cap color, the user will give some input now. So all these will be stored in this features one. After that, these features get encoded using label encoder. Every feature will get encoded, and then these features get scaled using standard scalar. After that, the model will be predicted just in the similar way, here, as you can see in the rf model. Here, the independent features first get encoded, and then we apply the scaling on the features. After that, we train the model in a similar manner. Here here the here the features get encoded. After that, the features get scaled. After that, the prediction will be happening. So if the prediction will be if the prediction is equal to e, then the result will be edible. Otherwise, it will be poisonous. This result will be transferred to the result.html page. If the result is not transferred, then we will get like error due to prediction in the log file. So let's try to run the Flask application. Here, as you can see, I'm just entering into the my Flask application. I have created a separate environment for my Flask to run my Flask application. So here I have activated my Flask environment. So log.py. So here my app has been run, and let's open this link. See here, you can see. So let's try to give the input for the data. So this is my input data. Let's try to predict what the model predicts. Let's see. Here the model has predicted it's a poisonous one. So let's see the log file, whether it has saved everything correctly or not. Here, this is my log file. Here you can see app.log. So let's go down, and here you can see today is August 4th. As you can see, August 4th, and the time is 9:35. So here you can see 9:35, and when I logged in, model encoders and scalar loaded successfully, and it checks another time. And first, I have already told you, when we access the home page, here you can see home page has been accessed, will be printed to the log. After that, these are my input features, and this is my prediction result. So okay, let's try to predict another one. Let's go back and just predict another one. Yes. So I have given my input features as like this, and just predict. Here you can see it's edible. So let's open another time the log file, and let's see. Here you can see we just logged in at 9:35:33, and I mean, sorry, it's 9:36. This one home page has been accessed, and these are the input features that I have given, and the result you can see is edible. Let's go back and test for another one more. So let's try to predict this one. Oh, the result is edible too. Let's close this one because it hasn't been updated. Let's try and open them one more time. And here you can see at 9:37 I have accessed the home page, and these are the features that I have given X, Y, Y, T, and the prediction result is edible. So in this way I have built my flash cap to predict whether by the given input features whether my mushroom is edible or poisonous. Thank you.